Hi everyone, my name is Ayşegül and welcome to AI Show. And me and Beatrice we are your hosts today, and we're going to talk about neural networks and about everything about neural networks. So thank you for coming, everyone. Jacob, where are you joining us from? Coding by Emp. Thank you for being our first person to be in the our chat and saying hi earlier. Hi, Beatrice. Do you want to introduce
Hello.
yourself?
Yeah, so I work with you, Aishul. We're on the same team. We're on the AI ML team.
And
I'm
I'm
a
very
dev.
happy about it.
Yeah, me too. Yay. So we're both dev advocates in AI ML at Microsoft. I love being here with you. So thank you. Thank you for having me on the show.
And thank you for being our expert today to tell us everything and answer our questions. I'm really excited about it. So for those of you who are not familiar, I work specifically with cognitive services on the AI/ML team and applied AI services. And there's so much that I don't know as well. So I'm really excited to hear about neural networks and AI. Hi, Paul from Australia. Wow. And we
Hi.
are really curious about where you're joining from. Oh, Pakistan. That's awesome. I know it's really late there, and I really appreciate you guys being here. It makes it worth it for us, really.
Hi, Giovanni.
Oh,
All right. So
that's
today, we're going to talk about neural networks, and we're going to give you a very gentle introduction to the topic, and we hope that you guys have lots of questions because 5 a.m., oh my goodness.
hello, Finn from Finland.
Yeah, so we hope you have lots of questions. Feel free to post your questions in the chat and let us know what's going through your mind. But I think that before we get into that topic, I think that Aishul, I want to hear how you got into AI.
Oh, yeah, that's it. Great question. So, I was working on mixed reality and on the spatial computing team, and AI is very integral part of the mixed reality world because you have to use for more accessibility. You have to use like voice commands, and mixed reality, augmented reality in itself uses lots of computer imaging to understand your environment, right? So that's how I get into it to help our customers do their mixed reality. Now I do work more with AI than mixed reality most days. How about you? How did you get in?
Well, so my background is in computer science, but not in ML. But while I was working my day job as a software engineer, I started getting interested in machine learning on the side. And after doing lots of online courses and lots of projects on my own, then eventually I decided to go back to go to grad school and learn it a little bit more formally.
Yeah.
Go ahead.
I'm really interested in that. I just want to say hi to Gloria from Canada. Hi.
Hi, Gloria.
And what made you decide to go back to have a master's degree? That's really interesting to me.
Yeah, so I've always wanted to do a master's degree since I finished my degree. I knew I wanted a master's degree in applied math specifically because my undergrad is in computer science. But it just never happened for so many reasons. Like I started working thinking I'm just going to work a couple of years and just save a little money and then go back to grad school. And then, you start working, you start getting used to having a salary or whatever, and it just becomes a little harder. So I just kept working and thinking it's going to be another couple of years, right? And then I got to an age that I thought either I do it now or I'm just not going to do it, right?
Mm-hmm.
And the fact that I was getting interested in AI, it just meant that it was just such a nice kind of area to combine with applied math. And so those two things together just kind of gave me the motivation to go back to grad school and just make it happen.
That's awesome. Hi, everyone. Mohammed and Taif from Africa. That's awesome. Such an international crowd. I love it.
Yeah.
Sometimes students come to us with their professors and they do ask like, is it important to go do, grad school? And it's funny to answer that question in front of the teachers, because teachers also know that if you go into the industry, it's really hard to go back to do the grad school. It's a rare thing. Most people stay working, I feel like.
Yeah, I completely agree with that. I think it took a little bit of, I don't know, like, I don't know, braveness. I don't know, like to just like leave my job, decide I'm going to go on a minimum wage salary, doing TAing to pay the bills,
Yeah.
and study, right? But it was fun, and I do feel like I learned a lot, and also I met a lot of really cool people that I know will kind of be friends for life. So that was great. But I would say that I don't think it's necessary to go back to grad school. I think this is not the normal path. I think most people don't go back to school to learn AI, and I think that's completely possible. Not just possible, like it's more like the normal path that I think people take to just pick it up and just study online and take courses or just do projects. So maybe my path was a little bit less traditional, but I don't regret it. I think it was fun. Yeah.
And you are inspiration, because I know you love it. So that inspires me to, I consider it sometimes. And we have Colin from Trinidad,
Trinidad. Oh my
and
goodness.
self-taught systems engineer, write codes around telecoms, and gonna try a hand on AI. Awesome. This is our goal to inspire everyone to try AI. And one thing that we wanted to, like, most of the apps that we use today uses AI, and we all need to use it, learn it somehow, if we are going to have our own products, for example, I feel like. Also, do we have any students? Pingas, let us
Yeah.
know.
Or
I'm curious.
professors.
Yeah,
Anybody
or
in academia.
anyone considering, that would be great. And how did you choose your subject? And what was your subject in grad school?
Well, so in applied math, we study a lot of PDEs, like partial differential equations, and also non-partial, also differential equations. And I've always enjoyed that kind of stuff. My husband studied that, and so I have access to a very nice library of material in that area at home. And so I knew I wanted to do something related to PDEs, and it just felt like machine learning, combining machine learning with PDEs was just like the perfect marriage.
That is really cool. So I know you have a lot to tell us today. So can you walk us through what we are going to talk about?
Yeah. So in fact, for that, I'm going to share my screen.
Awesome.
And just show you just a little diagram of what we have planned for you, not just for the show, but for the next few shows, or at least a couple shows. And so we want to start with an overview of deep learning, and want to answer all your questions, like all your high-level questions. So this will be more like a conversation, and we'll just talk about our experience, how we got started, and a few other things. So then we decide, we kind of think that a lot of people have, when they're starting, they have trouble with these two different questions, which is, do I really, I have this problem that I want to solve. Do I need to do a custom model for that? Or is there something available that I can just use? So we plan to kind of address that. And then the other question people have is, if they do a custom model, do they do it locally, or do they need to use the cloud? And so based on those two questions that we think are very common, we split kind of like the topics we're going to talk about into these 3 sections. And so in the first section, we're going to talk about writing a custom model and running it in your local machine. And to do that, we're going to follow an MS Learn module that was released by Microsoft that teaches Keras. And in the second section, we're going to talk about doing still a custom model, but running it in the cloud using Azure ML. So we'll give you just an overview of what Azure ML can do for you. And in this third section, Aishkal, tell us about it, because you're the expert in cognitive services.
So we are going to see how hard it is to do everything from scratch by the example of Beatrice. But and then after that, maybe we can talk about like how cognitive services have these pre-trained models for you, and even in some cases we have the applied AI UIs, which makes it so much easier for anyone who doesn't have the expertise, who haven't done uh, that much math and grad school can do. So I think it's good to see the difference too,
Yeah,
how
I think it's
fast you can
great.
get going.
Exactly. I think it's great. And I think that there's so much that can be done with cognitive services that does not require a custom model these days, that this is really where I think that the growth is going to be in the coming years, right? I feel like historically people, to do machine learning, you had to know how to to do everything from scratch. You had to learn all the math and everything. And I think these days that's changing.
Yeah.
Um,
And you
yeah.
can even do your own custom models with cognitive services for vision and language and so many other things, which is really cool. So for those of you who are starting new, it's good to understand what things are, and that's what we are going to talk about today. But it's a good place to start from cognitive services, even applied AI services, which have uh, more solution specific things. Like, for example, if you want to extract data from a form, we have the form recognizer, which you can get all of the images, face detection, text, and translation, all of those great stuff.
Yeah. Great. Awesome. So let's start by talking about deep learning and what is deep learning. And when I explain deep learning, I like to start by explaining how it fits in context with machine learning and artificial intelligence, because I know it's a common question that people get confused about in the beginning. So for that, I'm going to share my screen again and show you one other little thing here. And so the way I think about it is that we have AI, machine learning, and deep learning. And I think of deep learning as a subset of machine learning, and the machine learning as a subset of AI. And so what is the difference? Like, how do we distinguish between these three topics? So I think of AI as an area of computer science that aims to build computers that mimic human behavior, that essentially do something like humans do, right? And when I went to university, like not grad school, but like university a long time ago, the only class that was available to me was AI in this area, was AI, not machine learning. Machine learning wasn't really a thing back then. It existed, but it wasn't quite as common. And so we studied AI, like traditional AI. And with AI, there's many techniques to do that, to do AI. But and so there's machine learning techniques and there's non-machine learning techniques, right? And in the machine learning, if you use a machine learning technique, essentially what you're doing is you're teaching the computer to do something without telling it exactly how to do it. So you're giving it examples, data, essentially. So the computer will learn based on data, but not based on rules. But if you're over here, so if you're doing like AI that is not machine learning, then you really typically, there's many techniques, but for example, rule-based systems is one technique where you're telling the computer every single rule of how things work in the system that you're building. And so what are some examples of that? So Aishkul, do you remember when we were able to create a computer that beat Kasparov in chess?
I'm not a chess expert like you are, but I remember,
I'm
yeah,
not.
slightly, slightly seeing
I'm
it.
not.
You were more involved.
Uh,
Yeah, tell us
yeah.
like, so you're saying at the time machine learning wasn't that popular?
It existed, but it wasn't yet a thing.
Uh-huh.
So my understanding is that when IBM's Deep Blue beat Kasparov, I think that was in 1996.
Oh wow.
Yeah, I think that was at least just reading online. I see that there were a lot of chess experts that helped create that that software that beat Kasparov. So I'm guessing that there were a lot of like rules that were included in the software. So I'm guessing that that was more like a rule-based system
Uh-huh.
so it was AI but not machine learning. And another example that I think is similar but very different, it would be like here, like a machine learning, like something that is machine learning, but that is also AI, but is machine learning, is when DeepMind's Deep Blue beat, sorry, not Deep Blue, DeepMind beat Lee Sedol in the game Go, and that I think was 2016. That was pretty recent, and that was definitely not rule based on rules. That was based on machine learning or even deep learning. It's probably reinforcement learning, and so beating somebody or a world champion in Go was not possible with just a rule-based system. It had to be done based on like reinforcement learning and based on examples, learning by example. And that I think is kind of an interesting thing, because I kind of wonder, like, how do we learn? How do humans learn, right? Do we I feel like kids learn a lot by example, right? We're kind of watching, and it's, nobody tells us you put your foot on the pedal and then you go forward and then down and then you make a circle with your foot, right? So you just see somebody do it, and then you get on a bike and you're like, I think I can do it, right? And you just fall a few times until you do it, right?
Yeah.
So in a way, I feel like machine learning is a little bit more like how we learn. Maybe not entirely, and there's a lot of research these days to bring machine learning even closer to the way that humans learn, but certainly I think closer than non-machine learning AI was.
Uh-huh. That's fascinating, and I can't even imagine a chess game being rule-based, because there's just so much in different situations that you do different things, right?
Exactly.
That is so interesting. And Ty is asking if you can explain, I mean, if you have any idea about the search, like how the search actually works. And
I don't, and I don't want to make it up.
okay.
I do know people that do,
Hmm.
and maybe thinking about somebody specifically right now that does deep learning, machine learning, works I mean, at least he has a PhD in this area, and that works in search. That maybe would be a great person to
Guess
have
for
as
us.
a great
Yes.
guest for us in the future. Um,
Yeah,
yeah,
and we have the cognitive services search, the Bing search people that we will bring them uh, in the future. So let me understand. So I'm not a chess person, but like wanting that almost every company uses recommendation, right? Like let's say Netflix. So the first rule base would be something like maybe we have like woman like romantic comedies, like making super biased rules up from the statistic data and then recommend it. But over time it's so much more complex than that, right? Our choices are so much more complex. So it's
yeah.
probably just getting everybody's information, like myself, right, and then recommending me based on that. Is that right?
That's exactly right. Yeah. Like, can you imagine putting every rule that if you like this movie, you also like that movie. If you like this movie, you also like that movie. If you like this movie, you also like that movie. And yeah, and that's exactly why they didn't scale, right? These rule-based systems didn't scale, because there are just so many rules that you can keep adding and adding. And where do you stop? And are they correct? How do you maintain them? And then as data changes or life changes or whatever, like how do you keep them up to date? So they worked for, like, certain things, like, for example, they were very using, like, if you did a blood test, like, to determine, what's going on with you, or what, because then you can do, like, it's a little bit easier to say, okay, if this particular value is between this and that number, you're fine. If it's above, you might have diabetes, so talk to your doctor. So those kinds of rules were more like possible to add in a rule-based system. But even that, would get pretty complicated pretty soon. There's a reason why doctors have, I don't know how many year degrees to be able to diagnose diseases.
Yeah.
So, yeah.
Yeah, and Giovanni is asking the hardest part of is to choose the correct algorithm for your use case. Is there any
Yes. Let's talk
considerations
about
that you do?
Yeah,
Okay,
let's
yeah.
actually talk about machine learning and deep learning, because I think that's where you'd have the problem of choosing your algorithm.
Hmm.
So I'm going to share again, and go back to my little thing. So now you're here. So typically you're not going to be in this AI area too much. You're going to be in this area of machine learning and deep learning, and you're going to have to choose: do I do machine learning, or do I use machine learning or deep learning, and what's the difference? So let's start with the difference. So
Yes,
in
thank you.
deep learning, yeah, so in deep learning you're using we use algorithms that are inspired by the brain. They're neural networks, so they kind of look a little bit like the neurons in the brain and the synapses and all that. And we've realized with experience that deep learning does really well for big data. And so typically you would be here if you have a lot of data, then you'd be using some sort of deep learning algorithm.
Hmm.
There are many machine learning, and deep learning is newer than machine learning, which is newer than AI. So this is also kind of follows a kind of a temporal kind of line here.
Hmm.
But there are many solutions that like machine learning algorithms that are really effective. They're really good, that work amazing for small data. So often, like if you have small data, then just use machine learning. Like then that's fine. Then you don't need deep learning. And so
Uh-huh.
for algorithms such as SVM, um, is SVM is like a really good algorithm that does really well
What is SVM?
for it's what does it stand for?
Hmm.
SVM algorithm. Support vector machine. I should have known that.
What is it?
Yes. Support vector machine.
Oh, okay.
Yeah.
Huh. That's an interesting name. Yeah,
Yeah.
Arjun.
Yeah. And linear regression is usually where people start. There's many algorithms that are, and typically machine learning algorithms are based on statistics that has been around, so much longer than deep learning. And so they're definitely effective. So I do find that a lot of times people have a problem and they go straight to deep learning because I don't know, because it's a trend, because everyone's talking about it. It's just a cool thing to know how to do. And if you don't have a lot of data, you're not
Mm.
really necessarily better off with deep learning. Maybe a more traditional method works just fine for you.
Hmm.
And so how do you choose? That was really the question, right? How do you choose between one and the other? How do you know that you have enough data for deep learning? Often if I'm borderline, let's say if I have, let's say 10,000 data samples that would be like somewhat borderline between the two, I just
Uh-huh.
try both.
Uh-huh.
And I see what works better, right? So I always throw in an SVM and I throw in a neural network, and I see what works better, and I choose whichever one works better, right? If I only
Hmm.
have like 1,000 items, then I think machine learning would be the choice. If I have, 1,000,000, maybe deep learning would be the choice.
Uh,
So
so Giovanni is asking at what point the small data becomes a big data. Is I hear this term all the time in job descriptions a lot too. Working with big data. What is it? Do you have any idea? Is there a limit beside the big?
so it's all very subjective, right? Like
Yeah.
like it's a little bit, data science is a little bit more of an art than a science. It should be called like data art or something instead of data science. Um, but I think the numbers that I said, like I start thinking about deep learning when I have 10,000 or more,
Hmm.
and machine learning, like if I have just 1,000 or anything in between, then it's like a question mark. Up to like 50,000, I would probably still try a machine learning algorithm and see if that works
Hmm.
better. But often like a 10,000, then a neural network will work already pretty well, and if it does, then I'll just go with that.
Hmm.
So
I have a question. I know you did create a project recently trying to figure out if people are running versus walking from their smartwatches. Like, which one did you use and how did you decide? Just
It's a
briefly.
good question. So I have about 10,000 data items in that one,
Uh-huh.
and I use deep learning. I've done
Uh-huh.
that project before in grad school with the same data, not the same project, but I have used the same data, and I have tried an SVM. And so I know that deep learning works well. I know that I would get good results with deep learning. So this time I just went straight to deep learning. And also because I'm trying to teach deep learning. So I'm like, okay, I want like a small data set that will still work with deep learning, so that people aren't like waiting for, overnight to train. But not so small that I get bad results. And I know that about 10,000, I can get a good like 85% accuracy with that data set, which is pretty good. And it doesn't take people overnight to train. So that was a good compromise.
Yeah. So I totally forgot my question. The other thing that I was going to ask, I mean, we have questions from Paul. Is deep learning accurately simulate a neuron, and if that's the goal for the future?
Yeah. So it doesn't accurately simulate a neuron. I don't know if that's a goal. If there's more research going on to make it simulate a little better, there might be, but I would say that it's like loosely inspired, very loosely inspired. It's inspired in the sense that we have nodes that connect to each other and data that flows between those nodes, but we need things that the neurons in the brain don't need. Like we need to go backward and forward, or forward and backward in that order, through the neural network, which I don't think that the human brain does that. So there's like a few things that then evolved from that architecture that I don't think are inspired by the human brain.
And can you imagine? I feel like sometimes random pathways develop too, like randomly things just remind you
Connect.
silly things. Yeah.
Exactly. Yeah,
It's
that does not happen with computers.
Yeah, that would be a great way to make machines very not performant, honestly.
Right. I know,
Random
right?
thoughts. Yeah.
Yeah, random thoughts. Yeah. Yeah.
What about quantum computing? Amit asked.
Yeah. So again, not an area that I'm super familiar with, but I am excited to see the potential there, and the potential. I think we could easily have, like, with the power that quantum computing would give us, we could easily have machines that are more intelligent than humans very easily. So like it would be like the speed at which AI would advance will be just incredible when we have quantum computing, like in a more like universal way.
Yeah, it's amazing to think about. But also, one worry I have is like all of our passwords and stuff. It would be very easy to crack those.
To break them. I know.
Yes.
I know, and that is a scary thought, that we would have to then use quantum computing to come up with better ways to make passwords that can't be broken by quantum computers. It's just like this kind of catch-22 thing, right? But that is a scary thought.
So
deep learning,
go ahead.
Is deep learning closer to strong AI? I don't think it is. I think I don't know. You'll see lots of people in the AI field kind of having very strong opinions about this, like how close we are to having general AI, which is like when machines are as smart as humans. I mean, closer, yes, in the sense that every day we're getting a little closer, right? And people are making advancements every day. Are we like on the verge of it? I haven't yet seen evidence of that. But we'll see. I recommend a great book for that, actually, that I love. We were going to save this for later, but I'll say it now because it's relevant. There's a book called Superintelligence, by Nick Bostrom, I believe. That is just really great because it explores like all the like ways, the possibilities of like how, like if AI becomes as intelligent as humans, or if it passes human intelligence, what will happen? What will happen to us? What will happen to the world? And what are the many different ways that it can go correctly, that we can all be happy and live in a better world, or that all the ways that it can go wrong? And how can we avoid the ways that it can go wrong? How can we start preparing now to not kind of follow into those pitfalls? What year will Skynet take over the world? I could give you an answer like next year, but
What is Skynet?
oh, can you answer, Giovanni?
I'm guessing it's the metaverse of mixed reality. Everybody keeps talking about metaverse.
Terminator.
When it's going to happen. What is it?
From Terminator.
Oh, I see. I
Right?
see.
It's like yeah.
Yeah, we actually, I don't know if you can see the headsets behind me. It's very close to Terminator stuff. You can basically look around and identify things. Oh, okay. I haven't seen it in a long time. And we passed one question, just bringing to your attention. Support. What are support vectors? Ginger asked.
Oh, yeah. So I would have to go look that up again, right? Support vector machine. I'll have to go look up. So they are something. You know, support vector machine is called that because it works with support vectors, but I don't remember exactly the details. Yeah, I don't remember details. I would need a couple of minutes to refresh my memory.
Okay.
But you can look up, like literally, just search for support vector machine, look on Wikipedia, and see what the support vectors are.
And we can answer that next time too. We can take a note. Like, come back. I know it's too late where you are, but sorry.
Yeah.
Can I write AI code only using C#?
That's also a good question. These days, most people use Python. So I personally, my background is in C#, by the way. Like, so I've done that for like 10 years or more. And I chose to switch to Python when I started doing AI because that's like the main language that people use. So, and I do think that there's a big benefit in being and using the language that people are using in the field. Now, you can do a lot with C#. You can do a lot of C#. If that's the language you know and you don't want to get deep, if you don't want to get deep into AI, then by all means explore what's there.
Also, you can use cognitive services, which are pre-trained AI models without having to be an expert in it. And all you do is you can use the SDK. We do have a C# SDK, very well supported. But also, all you do is have a REST API, right, to make a call, which is really, really cool.
Exactly.
Let me have.
And by the way, Chang here, I think Aishikal has a lot of headsets. They're not headphones. She's really into mixed reality. She's like mixed reality expert.
Yes, those are all Microsoft except one of them, the white one. So yeah, if you have questions, we can answer, like the relationship with mixed reality and AI. We could even do a one show maybe one day.
Yeah, that would be. I would love that. I would love, because I think I would learn a lot from that.
Yeah. Paul says F# is perfect for AI. Yeah.
And I believe you.
Let us know, like what other languages people are using. I'm curious. Sorry. Go ahead.
I would love to hear that. Yeah, and also I'm thinking R is also a popular language, especially people who have background in statistics. They like to use R because it's very popular with statisticians. And then another one that is up and coming is Julia. And Julia I'm very interested in because I think it's a really, I wish it was more popular. If it was more popular, I would switch.
What is that?
Python. Julia is very similar to Python, but it's super performant and it's typed. And coming from C#, that's one trouble I have. Not trouble, like I've gotten used to Python. Now it's my main language, but I do wish it was typed.
Yeah. Now there's ways to make it typed, right? Python?
No, you can give it type. Like I always write my Python with type kind of hints, but the language doesn't enforce that.
Oh, I see.
So it's, the types are there, but if I make a mistake in the types, it'll still work. And my understanding of the type may be wrong, and you'll be reinforced by me putting the type there. So it's not ideal. So yeah. Julia is very interesting.
Never heard of it, actually.
Yeah, it's only used mostly used in academia these days. Like I got introduced to it in college. The guy that is writing it came and gave a talk, and so we got, yeah. But I also had already met a few people that were really into it in college. I had essentially switched from Python to Julia and swear it's the best thing ever. And also it interoperates really well with Python modules and C++ and other languages. So people who do Julia say, there's no disadvantage, because yes, there's more of an ecosystem in Python, but I can still use that ecosystem from my Julia program. So that, I think that's another reason why it's getting adoption. So yeah, but I'm still in Python because I do like being able to look at online at an example and just be able to understand it easily, right? And most of the time, the examples are going to be in Python.
Yeah. And yeah, I love Python. Was the first language I learned, really learned.
Oh, really?
And yeah, it's such a, simple and nice. Yeah, I really appreciate it. We have a bunch of questions. So what about Cortana? Cortana is our speech assistant, voice assistant, and we have it in our products. Like one of the headsets is called HoloLens, which and you can basically tell Cortana, like you do interact with Cortana a lot. You can also use it on your desktop, right? Have you ever used it, Babe?
I have. I don't use it a whole lot, but I have used it on occasion.
Yeah, I think it's more useful in mixed reality context because things are in 3D space and far away, right? It's much easier to just ask Cortana to do something than press a button most of the time. Anybody else is using it?
Somebody saying Cortana sucks. Yeah, it's funny because I have an Android, so I use Google Speech quite a bit, and we also have Alexa, so we use the Amazon. And then I have a Surface, so I do use Windows, so I have Cortana. So sometimes we do make little competitions at home.
You do? Oh, that's awesome.
Or we ask the same question to all three to see what they come up with, to see which one is more helpful. That's interesting. And sometimes it's funny, right? They say things that are so unhelpful that they're funny, right?
Yeah.
So
one thing I find really funny is I have Google Home and I have smart lights. So I tell Google Home to turn the lights on, and it pretends to turn it on. It says like, ding, and then it doesn't. It's just hilarious to me. Well, AI has, it's still a work in progress, and there's a bias. Like we do expect more from AI. If you include AI, like when it doesn't do the right thing, we are more disappointed from
I
the
agree.
Yeah, there was a research about it, which is interesting.
Interesting.
So,
okay.
Did you figure out any strengths or weaknesses on particular ones? Or
on particular
the voice assistant?
The voice assistant. Well, I do like my Google Assistant, I gotta say. It usually gets things right most of the time, I would say.
Yeah, it just started to talk to me in Chinese suddenly. I fixed it yesterday, but it was I don't know what happened there. Okay.
Oh, Siri, that's right. There's also Siri. So my husband has an iPhone, so we do put Siri in the mix. We do, yeah, we use all four. Yeah.
Okay. I have a determining question. Which one tells the best jokes? You have to test that.
All right, next show. I will test it and I'll let you know.
Yeah. Okay. What are AI tools using for tracking system in car taxi business?
So what AI tools, for car, you mean for autonomous cars, or where is that question?
Yeah. Little up.
Little up.
Yes. What are AI? Well, yeah.
I can't find it anymore. But for autonomous driving, it's there's a lot of vision. So CNNs that are being.
Here we go.
Oh, there. What are the AI tools used for tracking system in car taxi business? I don't know if you mean for routing or if you mean for autonomous driving. The future or the present, right?
Yeah, I'm guessing lots of computer vision, right? To detect
exactly.
a lot. And then, but still, you have a decision part of it too. Yeah.
Right. Yeah, so I'd say for autonomous driving, I would say a lot of vision, also sensors and all that kind of stuff. For what we have today, you know, just like the routing, then that would not be vision. It'd be other techniques. I'm not even sure how much they're using AI for those tools. I don't know. Again, I don't work in those tools. I don't know for
Yeah.
sure. Just guessing here. Yeah.
Yeah. Um,
So
yeah. To see code for
autonomous. Yeah. Do I have any thoughts on autonomous transportation? I can't wait for it to be here because I hate driving. That's my main thought. Yeah. So, do I have any thoughts? I mean, really, like we're getting there, right?
Yeah.
We're getting there. I do think that sometimes people think, again, what you were saying, right? People think that we're there already, especially with certain cars, and we're
Yeah.
not, right? So,
Yeah.
but we're definitely heading in that direction.
Yeah. I like the assistance. Our car tells us, like, if you put on a cruise, it's, knows when you need to brake, and like it knows if you are very close to, and which is really, really nice. And I rented an older car recently, and I was like, I really depend on this. One thing I really
Right.
wish is also help with the parking. I think
I
AI can
know.
do
I wish
much
I could
better
just
parallel parking.
press a button, press a button in parallel park. I know, like, yeah, that would be awesome.
Yeah, I saw it
Already, like,
in a commercial. I think one car has it, but I don't know which one.
oh, really? I want
Yeah.
that car. That will be my
Yeah.
next car. I agree.
Um,
Yeah, I think already, like, even like staying within the lanes, you know, like kind of seeing the lines and kind of helping you stay within the lanes is already pretty
Helpful.
helpful.
Yeah,
Yeah.
I think so too. So do you see the question on the screen? I don't know if you are seeing it.
Oh, yeah. I love to see the code for creating custom model from scratch and design choices that are being made. Okay, we're going there. That we're going there next.
Yeah, that's our
We
plan.
can, yeah. We
Stick
can go
around
there
for the
now,
question.
or okay. So stick around.
Let me go through the questions really fast.
Sure.
There are so many variables
There
to get right.
are,
Yeah.
yeah, and I will talk about that.
Yes.
You're absolutely right that getting them right is the best.
Oh,
The book that I mentioned is Super Intelligence by Nick Bostrom.
I'm writing it to the. I
The
misspelled
chat.
it, but yes. So there are many variables to go wrong. We'll talk about that. And Paul said F has very strong type inference, 10 times more performance than Python. Wow. That's
Yeah, that is. I'm not surprised. Python is not terribly
no,
performant,
yeah,
and it does not have types, which are my two main issues with it. So I
yeah.
totally see. I can imagine that other languages are getting that better.
Yeah.
Author is Nick Bostrom. I don't know exactly how to spell it. Bostrom or something.
Bostrom. Yeah, it is.
Yeah, you found it.
Okay. Yeah, I did.
Yeah.
I'll put it on our chat. All right. So is Microsoft planning a big on AI? Well, my answer to you is
yes. Always.
come to Ignite, which is around the corner. I had a link for it. I'll show it to you now. So Ignite is on November 2 to 5, is it? Do you remember?
Yeah, that's
and
correct.
there will be an AI keynote. We'll work on some demos too, Bay and I, hopefully. And yeah, you can hear all about it from Satya and other people. Oh, I can't find the link, but I'll put it on our chats. So next question. I'm trying to go in the order so we won't. Python is the first language I abandoned back in the day. Somehow it didn't compute for me. Oh, interesting. I always thought that's a good, more understandable language. But yeah,
really,
I haven't.
I think it's what you start with becomes easy for you.
Yeah, I actually haven't used it in any projects like in my professional life, right?
Okay.
So I don't know. Python doesn't scale. Yeah,
Yeah,
it was
totally
created as
true.
a scripting language. That might
Right.
be. But there's a lot of companies in Silicon Valley. I know that they're using Python
Mhm.
exclusively.
Right. Right.
We have Cortana sucks. Yeah, sorry. Let us know like what kind of issues that you're having. Also, we would love to give the feedback to the team. So we are
Yeah.
actually close to the teams. Okay, Cortana always gets things wrong for me, and I dish it. Yeah. So if there's any specific, please let us know. Do you have any thoughts on autonomous transportation? I'm looking forward to it. Yeah, we covered that, I think.
Yeah. Yeah. We did.
What about motion capture?
Mm.
I'm actually we do have a amazing motion capture studio here in SF, San Francisco, and also I think few other places in the world, which is London, I think LA maybe. It's being used by movies a lot. So I think anyone can rent the motion capture studio to create, uh, their 3D action thing, which is really, really cool. Um, yeah. And how AI is working toward motion capture. Um, Well, the thing that's happening with the motion capture, so everything is green in the background, and we have millions of cameras basically all around you, right? And the cameras are taking in not only the image, but also there's a depth sensing, just like on Kinect or any augmented reality application. We do have the depth sensor. So what's happening is taking in all of the action and trying to maybe take out the even the person, so, and then replace it with a computer graphics generated monster, for example, right? So people perform, but you got all of these like points all over them when they perform, and you get all of that information and then transfer it in an animation of a creature. uh, or like it could be the actual actor, and there's lots of computer vision going on to be able to replace things and take out things basically. Can you Okay, Paul asked, can you post the book? Yeah, I did. Wow, is it I'm watching live? Yes, Ozra, you are watching, right? So okay, where do I start was the other question. I just lost it.
Yeah, that's
Um,
exactly what we're going to cover today.
okay.
Like to start with Python and a, a neural network. Yeah.
What is the pricing for motion capture rendering studio time? I have no idea, but I can find the link for you and put it on the chat in a few minutes. Any words on Windows 11? Well, Beatrice is using Windows 11, I know. So tell us about it.
Yeah, yeah. So I've actually been using it for a while, like since it was made available to us, like with the Windows, like with the whatever that like the, yeah. If you get like the early releases for Windows, um, I really like the window management, the new window management of Windows 11. I think that's my favorite feature. I also love the UI. So I'm generally happy, and it's been pretty stable for me, even before the release, even the months leading to the release that I've had it. It has not flaked out on me too much. I trust it enough that I'm using it now in live video, and I'm not too worried that my machine will crash. Although if it does, please understand. But yeah, I'm pretty excited about it. Yeah.
I am pasting the motion capture studio link down there, and there's a cool video of how they do it. So one thing that they do with the caption studio is, for example, a dance show they recorded, and you can actually see it in 3D with the augmented reality glasses, which is really nice.
That's awesome.
What are massive advances in AI in diagnostic medicine? Oh,
Yeah,
tumor
I'm
detection.
sure.
Yeah.
Yeah.
I think I read at some point that is the most successful was radiology, because detecting the tumors. And interestingly, radiology is the least accurate. Uh, like, radiologists make the most mistake, because apparently they don't get the feedback when they make a mistake. So because of that, it is an area that there's lots of mistakes, and it's much accurate with computer vision, which is really cool. And the other thing, that it's not diagnostic, but the other thing that Microsoft has is Cognitive Services Text Analytics for Health, which, let's say you want to record your conversation with your doctor, and then it's allowing your doctor to just take out the important information and then give all of the information, so that your doctor, instead of typing in all the time, that's what happens in America. Instead of talking to you, the doctor can focus on you, and then all of the important information will be typed and then summarized for the doctor, which is really cool. It's called Text Analytics for Health. Okay, so here we go. Prerequisites for using AI.
Maybe we should just go into that. Go into like there's enough people asking about it. Let's just go for it. Okay. So to start coding with Python, my current recommendation is, so Microsoft has these MS Learn modules that help you learn right on the web, like where you can actually run code that is already there, and so you can see it run, you can modify it, you can run it again, and they're meant to be for beginners, right? And they work with Jupyter notebooks. Or notebooks, not Jupyter, but like with notebooks, which makes it a little bit easier for beginners to start, because it means that you don't need to set up anything on your end, and you start getting familiar with the topics without actually having to install a bunch of stuff and everything. And we'll cover everything that you would install, or that you will have to install to do that on your machine. But what I'd like to go through is, I would love to go through the of like a TensorFlow fundamentals learning path with you guys. And so what I recommend is that you all go to that link, akm.ms learn Keras, and follow along with me. And so I'm going to share my screen, and then we can just do it together. And so, all right, can you see my screen?
Yes.
Okay, so when you go to that link, you should, so actually before I go here, so there's like a TensorFlow fundamentals learning path that Microsoft put out that has several different modules. So the one that we're going to go through today is this introduction to TensorFlow using Keras. But there's also one on computer vision, another one on NLP, natural language processing, another one on audio classification, and another one on going beyond, like customizing a code a little bit better, with just using TensorFlow. And so we're going to do the basic one here. And by the way, there are several different technologies that you can use to do deep learning in using Python. Here we're using TensorFlow, and TensorFlow has a library called Keras in particular, which is what we're doing here. But there's also PyTorch. PyTorch is also extremely popular, and which one you choose is really up to you, right? We're going to start with Keras because I find that Keras is a little bit easier for beginners. But I also love PyTorch. I don't necessarily have I don't really have a preference between the two. So here's what we're going to do. We're going to go to the data section, like where I skipped introduction. So it's going to tell you it's going to ask you to activate the sandbox, which you'll need to do, and it's free, and just allows you to be able, oh, I don't know why it's asking me that. I hope it will just activate. I hope it'll just work. No, okay, I'm gonna have to stop sharing then, because I don't want all of you to start calling me. Oh, all right. This is probably going to take a while.
Oh,
So,
I was on mute. Sorry.
oh, you were? Sorry, you were
Yeah.
saying? What
Yeah.
were you
No.
saying?
Also, like you are signing in, but everything is free when you do the Learn module, right? You.
Exactly. Everything
Yeah.
is free. Yeah,
Yeah. Uh,
exactly.
that's everything runs in there. You don't have to set up anything. But Beatrice is going to show us how to set up your computer too. So stick around for that. But for this one, you don't need to do anything. But please do follow along, and
Yeah.
we can. Let's see if you have questions. And yeah, there are a few
And
questions here that I can answer while you're doing that. Let me know when
uh,
you're ready.
it's
Oh, you
actually
are.
ready. Yeah,
Okay,
I just
cool.
had to enter a code. So if that happens
Yes.
to you, just get a code on your phone and then you just enter it. Um, so the idea is that there's like little snippets of code. That's how notebooks work. There's little snippets of code, and you can run them. So for example, I can run this one just by pressing play there. This first one will take a little while because the machine is like the kernel is restarting and everything, or starting. But that's the idea. And so typically when you do a machine learning project, you typically start by looking at the data and that you have and processing that data, because you don't always get data in the format that you want, right? And so in this case, what the project that we're going to be doing is we're going to be we're going to be creating a neural network that takes in images, like an image, and it classifies the kind of clothing item that image is. And these are the different clothing items that the neural network is able to classify. So this is, we have here that. So I'm just going to run that. And so to load the image, I'm using the fashion MNIST data set, and it's actually a very common data set. And if you're doing it on your machine, you would actually just do this line, not everything else that's here, to load the image, to load the data. But we have certain restrictions in MS Learn modules, so we weren't able to do that. We weren't able to just connect to different servers outside of Microsoft, and that's why we do this, like we have it cached. But on your machine, you would do this. But I'm going to run it. So this essentially just loads the data, the fashion MNIST data, so the images. And here we have a little bit of code that will show you the actual images that we just loaded, that it just inspects the images, and it prints them, or it shows them. Take a little while. So here they
Oh,
are. So it just like shows like 9 of them.
so
They're very, go ahead.
yeah, can you tell me why they're so pixelated and black
Exactly.
and white? Yeah.
That's exactly what I was going to say. So they're very low res. They're 28 pixels by 28 pixels. And the reason why they're like that is that this is a very common data set, very popular data set that is used for learning. And machine learning can take a long time to train. And so we just have very small data, so it doesn't take a lot of time to train. But you can still sort of like look at each of these images and tell what it is, right? So obviously that machine learning would work with much higher resolution images, but it would just take longer to train. I mean, we don't want to be waiting here forever when we're learning. So that's really the reason. So this is just some Python code. We're still not doing any machine learning here, so I'm not going to go very closely, like very slowly. But you can, like if you're doing this on your own, please do look at the code and play with it. And then we're going to look at one of the training labels from the data set. And so we get a 9. So the training labels are really ints. And a 9 really just means that it's an ankle boot, because of this is like how we map from int to a string. And now we're going to look at an
Integer, by the way.
yes.
Just because it's not, you know,
Yes,
Americans.
integer. Sorry, you're right. Yeah, and we can also look at an image. And if you look at an image, we'll see that it's an array, like it's a 28 by 28 array. So it's really a matrix, because it's like a 2-dimensional array. And the numbers are the pixel values. So like from,
Black to
this
white.
is black to white, exactly, that's it, right? So you get from 0 to 56 somewhere. Actually, machine learning doesn't do very well with this. So one of the things that we do is, Did I run this? Okay. So one of the things that we like to do is to process our data before we consume it, to actually do some data processing. And so one of the things that we do is first we get data sets. I'm going to skip this part. So we get data sets because they're easier to work with. Like when you do a for loop, they're generators, which will give you just like a little bit of data at a time. And you'll see later why that's important. But what I was getting at is that we need to process the images, so the actual numbers that you saw, the pixel values. And we would really like them to be, first we'd like them to be floating points, meaning like not integers, like something with a dot. And we don't want them to go, we want them to go from 0 to 1. And typically this works better for machine learning. And so that's why we typically do that. And so now when we look at an image, instead of being from 0 to 255, now we see that the values are from 0 to 1 and that they're floating points. And they're still going to be 28 by 28. So it's still going to be a two-dimensional matrix of values. So this still represents the same image. And then we also need to set a batch size, which we'll look at later again, because I was saying we're going to use process a little bit of the data at a time, and we have like a good 10,000 or close to 10,000 clothing items, and we just want to work with 64 at a time. We also like to shuffle things because if there's like any order in which things the data is given to us, we like to shuffle it to make better predictions. It just makes it better, makes it work better that way.
Say it one more time, what you just said.
Yeah, so like if you have, generally, we shuffle the data because we want the data to be random, like the order in which the data is given to us to be random. And it's not always random. Like if you're given like first all the ankle boots and then all the t-shirts and whatever, we prefer that each batch of size 64 gets a good variety of those images, like that it gets a t-shirt and a boot and whatever, rather than just getting all t-shirts and then the next batch gets all boots, because it will work better that way. Like it will be able to distinguish between each batch will be able to distinguish between the different images.
Oh, I see. That's interesting. I didn't know that.
Yeah. And this just prints the batch size, which is 28 because I haven't yet run this.
So, question: what happens if I'm training for 65 different images instead of 9, I think, or 10 you had? 65 different item.
Oh, yeah.
So 64 will be missing one, each 64. Would it eventually even itself out?
It would, yes.
Okay.
Yeah. And actually, one of the questions we had earlier was like, how do you know which parameters to set? Like, how do you know that you set a batch size to 64? Like, and the answer to that is you don't. You try it, right? So typically, here, because this is a beginner thing, I set the batch size to 64 without thinking too much about it. But if I'm doing a project for real, what I'll do is I'll do hyperparameter tuning. So I'll try many different parameters, and batch size is typically one of them that I try many different values for it. And then whichever one works better, then that's the one that I go with. So there are no magic numbers. Like 64 is not a magic number. It's just something I picked for this problem because I know it works well for this problem. But for your own problem, you'd have to figure that out. You'll have to try lots of different ones. And there are ways to do it not by hand. There's hyperparameter tuning software. Yeah, so typically that's what I would do. I would never do this by hand. Like my favorite hyperparameter tuner right now is RayTune. So that's one that I've been using quite a bit, where you specify, let's say, all the batch sizes that you want to try, and it will run your program many, many times until it finds the correct one, the one that works best.
I see. I actually had a question earlier, a similar question. So you also said that you would try different algorithms in a project. Like, how easy is that? Because it might be complex.
Yeah, so I would use the same hyperparameter tuner because Yeah, so you can choose different algorithms, but you can also configure a particular algorithm in many different ways, because there's, let's say, in this case, we're going to use a neural network, and there's many ways to configure that neural network. So I would start by, using RayTune to configure the neural network in many different ways, find my best, and then at that point, maybe compare that with SVM, maybe by hand, because then there's just two things. So I'll probably just do it by hand at that point, or maybe, because there's also parameters that you can configure in SVM. So maybe I'll do another RayTune pass with the parameter that you pass to SVM, and find the best parameter. So then get the best prediction using SVM, and then just compare the two and just decide whether I use SVM or neural networks. Yeah, that's what I would do. So this is really just like some data pre-processing that people do. So, and just to summarize, we typically, for images, like there's all sorts of data, but for images, what you see here is we typically go from pixel values between 0 and 256 to floating point between 0 and 1. That's really the major thing. And also you need to think about setting a batch size, and also setting, so creating a data set, setting a batch size, and also shuffling the data.
I missed the last thing you said about transferring its flow to.
Yeah, so typically, because we want the values to go in, we don't want the values to go from 0 to 256. We typically want them to go from 0 to 1.
I see.
And so
Okay.
if they go from 0 to 1, they have to be floating points, right?
Gotcha.
They have to, Otherwise, it would be all 0 or 1, which we don't want. Right? Yes. So that's why we convert them to floats. Awesome. So that's generally, if you have images, that would be like the basic pre-processing you might do. You may do other kinds of processing if you have images. Like you may do things like data augmentation, where you like crop the images in different ways and then use those also as input to your neural network. Or that you rotate the images or flip them. So, yeah.
Why would you rotate or flip?
Because it's another data point. Like especially if you don't have a lot of data. Yeah, especially if you don't have a lot of data for your neural network, that's like another data point that you can have. Like, a T-shirt is still a T-shirt if it's rotated, right? Gotcha. And you want your neural network to identify rotated T-shirts.
That's a great tip.
Yeah. Okay, so typically, just as an overview, actually, I want to go back and actually look at the overview, because typically you start by pre-processing. I feel like I started this like a little bit too fast.
Yeah.
I did. I know I did. I'm more worried about time. That's it. But yeah, we have plenty of time. So typically, when you're doing a machine learning project, you start with the data, by pre-processing the data, and you kind of do what we just saw. For example, if you have other kinds of data, you may do other kinds of pre-processing. Then you create your neural network. So
I have a question. Sorry, about data. I don't know if you see me. I did lots of data visualization, and 80% of the job is cleaning up the data. So what is the percentage here when you say data?
Yeah, so because this is a data set that is very popular for learning, we don't really need to clean it up. But in
real life.
No, that is definitely not real life. If you're doing a project in real life, I would say a significant part of your time as a data scientist would go into cleaning the data. Yeah. And that could be like data points that are just incorrect, or just, I don't know, just all sorts of issues that you would, and you'd start by like looking at the data and kind of getting a feel for it before you decide like, what do I do with it, right?
Yeah. So how do you do that? How do you do that part? Like, how do you look at the data? I mean, I'm sure you're not looking at the individual data points. Is there a tool that you use?
Yeah, there's several like libraries that you can use. Like Pandas is a really popular one with data scientists that allow you to look at your data in a tabular way, and then has a bunch of different methods that you can call that will help you clean up the data. Some of them just clean it outright. Others just help you detect patterns. So that's probably what I would do. Yeah, in this case, that wasn't needed, but in real life, that is needed.
Yeah.
Yeah.
I think I used Tableau once to look at
Yeah.
to do a Kaggle project,
Yeah.
which yeah, which is a visualization tool basically, but you can try to visualize in many different ways. And we also have Microsoft had Power BI.
That's right. Yeah. Those are
Yeah,
two great choices. Yeah.
especially if your data is on Azure. It's I think it's really easy to integrate it with Power BI.
Yeah.
So I'll put the link here.
That's awesome.
Okay. But in terms of cleaning, it doesn't help. So does the tool that you mentioned help?
It does, yes, yeah. So I
Oh.
think the tools that you mentioned are actually extremely important to be able to understand what you need to do to clean, like what needs cleaning, right? What is the data about, and what do I need to do? And I think that with pandas, you could then do the actual cleaning, right? I use NumPy a lot also, which is able to deal with so with matrices of any dimension. And so that's really useful for the kind of data that I use, that I typically work with. And that also has a bunch of tools, like a bunch of like methods that I can use to find patterns in the data and to clean it up.
Yeah. And now your data is very clean in this one, but
Yeah.
let's say it wasn't clean. What kind of data would you take out? Like what would be not clean?
Ooh. Let's say if I got an image that was just static, instead of I would probably in data like this, especially just 10,000 images, I would just look at it by hand or by eye or however you would say it. But I would just look at it manually, and I would just try to look at like, okay, like maybe this image was like is just static. Maybe it's just all black or all static. That it's not a clothing item. I would just remove it.
Oh, I see.
Or
Yes.
if it's like so blurry that I can't even as a human know what it is, right? I look at it, it's like, okay, this is so blurry, I don't even know if this is a shoe or a sock or a pair of pants, right? Then I would remove that, right?
I see.
Or if I get some image that is color or that is not a clothing item or that is not 28 by 28, because we assume that it's 28 by 28. So those would all be things that I would look
Yeah.
for.
Yeah.
Yeah.
Well, I did a custom model training for custom vision with cognitive services to figure out if it's a VR headset or HoloLens, which is the augmented reality headset, basically. And then I was looking at the images. There's like really weird looking VR glasses, and also there's this thing called cardboard, which is just a you know looks like a box. So I
Yeah.
actually eliminated all of those interesting headsets
Right.
because it was just going to make it much more complex.
Yeah, totally. I get
Yeah,
that.
yeah.
Exactly.
But I could have used the same images by flipping. Such a great idea.
Yeah, exactly. Yeah. So that's used often when you don't have enough data, right? If you have uh, not enough images, that you would augment it. And there are tools to do it, so you don't have to do it by hand. So you could just have a bunch of images and then just with some code say, okay, now use all those images flipped. Now
Yeah,
do also those images rotated or cropped in the middle or cropped in the corner or whatever. Like you could just do that in code.
yeah.
Yeah.
Just for anyone who's interested in seeing and no code AI, like without writing any code, how to train custom model, I have this blog post that you can check out. Okay,
Awesome.
self promotion.
Yeah.
Continue.
No, good one. All right, so I do want to talk about the overview before I dive deeper into each of them. So we look at the data, and that's typically the first step. Like you pre-process data, you clean up the data, you see if you need to do anything to the data that will make it better to be consumed by a neural network, right? Then you create your neural network, and at that point, you know exactly what data you have, so you can customize that neural network for the size of the data that you have and for the type of data that you have. Then once you have the neural network, then you need to train it and then test it. And to train a neural network is to find certain values in the neural network that make that neural network effective at doing something, gathering the information that you need for your data. So in this case, this project, our data is a bunch of clothing items, and our goal is to classify those images with the clothing item, right? It's like if we get
sorry, finish your thoughts. I have a question.
Okay, so it's like if we have like an image of a boot coming in, we want the output of the neural network to be the word boot. And so that's really what we're looking for here.
Okay.
Go ahead.
And on your graphic, we had AI, machine learning, and deep learning. We haven't, well, maybe you mentioned, but I missed it. What is the relationship with the neural networks? Where does it fit
Yeah,
in?
so neural networks is deep learning. Essentially,
Okay.
in deep learning, so when you're using deep learning, you're using a neural network. That's the algorithm that you're using, right? So you're using a neural network to solve your problem, right? To give you your answer. In our case, our problem is we have a bunch of images and we want to classify them. We want to classify, like, say what it is, right? But there are other kinds of neural networks that do different things.
Awesome.
Yeah.
If you have any questions, meanwhile, please feel free to put it on the chat. There were a few of them I missed. Prashant said by data scaling, right? I'm not sure where you asked that question. Sorry about that. And if you want to ask it again, that'd be great. Go ahead.
All right. Okay. Then we train the neural network, which means that we customize the neural network so that it will work for our problem the best. So it will be able to classify the data that we give it. Then we test it to make sure that it works, like that we can give it an image and we actually get the right thing back. And then once it's trained and tested, then we can actually use it to make a prediction. So we can actually give it an image and get a string back in this case. So that's really the overview. So we did already the data part, and next I want to look at the neural network.
Okay. Before you do that, we have one question. Is there any blog or tutorial that is about ML for voice and text, other images like you have showed us? Are you aware?
Yes. For text, we have in the same fundamentals, TensorFlow fundamentals, NLP, this one. NLP is all about text.
Are you able to paste that on our chat?
Yes.
Okay.
I will do that.
Yeah, the link.
I just need to be able to click on it for some reason. Okay. This one. Okay, I'm going to stop share for that. Okay.
Oh, all right. Awesome. Thank you. Go ahead. Yeah, I'll paste it. Don't worry. You can continue.
Okay. Okay. And so one of the questions was NLP, and the other one was?
Voice and text and other images. And
voice, yes. Voice also here. We have this audio, this one, audio classification.
Yeah. And this is if you want to do it from scratch yourself. If you want to do it for with cognitive services, there is cognitive services AI modules too.
Right. Maybe we can go through one of them in the next episode.
Yeah, that's a great idea.
Like the birds one, or some other one.
Good one.
Yeah. Okay. So now I'm in the neural network section. So I'm going to start by importing what I need. And so this is what the neural network looks like. And this is why I said that it's a little bit inspired by the brain. It's inspired by the brain in the sense that there's neurons, which is those circles that I put there, and there's connections between the neurons, right? There's those lines that connect the neurons, right? That's the extent to which it's inspired by the brain, nothing more than that. And so the idea with a neural network is that we get in an image, so we give it an image as input, which is 784 pixels. We need to have 784 of these neurons to accommodate each of the pixels of the image. And then it does, it connects all neurons to all neurons, and it does some processing, which I'll explain. And then at the end, we get a vector. And this vector has 10 positions, right? So it's a 10, size 10, right? A vector of size 10. And each position will give us how likely it is for that image to be of that class. And we had 10 classes before, if you remember correctly. And they were I showed a string that classifies each of the classes. So each of these positions corresponds to a class, like a type of clothing. And the one in index 9 is an ankle boot. And so when we get a vector like this back, the highest value is this one at the bottom. And so that means that this image is an ankle boot. Okay, this is a lot, so I'm going to leave some time for people to ask questions. And I can repeat what I just said, because this is the most essential part of deep learning. This is it. If you understand this, you know deep learning.
Okay, I got distracted. Tell me one more time.
I will. I will. Anything I should be looking at, Ashko? No.
No,
okay.
No, you're fine.
So, so here's this. So a neural network has a structure like this. So there will be typically an input layer, which will be the first layer of the network. There will be one or more hidden layers. There could be many of these. And there will be one output layer, which is this. And the input layer will typically be, in the case of an image, because we're talking about images, if we have 784 pixels in the image, then the input layer will have 784 neurons, 704 of those nodes. And each of them will be receiving a different pixel from the image. Okay?
Uh-huh.
All right, so the neural network is specialized to the size of this image. And this is why we chose a small image, because 784 is already so much that if we go much bigger, then it will just take longer to train. So that's why we're doing this.
Okay.
Now the hidden layers, they can be highly customized. Here we just have one hidden layer that has 20 neurons. You could have a much bigger neuron hidden layer. You could have multiple hidden layers. How do you choose? To go back to that question that we had at the beginning, how do you choose? Well, you do hyperparameter tuning. So this could be a parameter to your network, like the size, like how many neurons how many nodes the layer has, how many layers you have. Those could be parameters that that then you use RayTune or another tool for finding the right number of hidden layers and the right number of nodes within a layer. In this case, this is just a very simple introduction tutorial, so we just chose one hidden layer with 20 nodes.
So why are they hidden?
Well, it's just a name. They're not hidden in the sense that you can look at them. They're there. They're called hidden layers because they're not output and they're not input.
I see. So, interesting.
That's it. Because typically that's what you deal with, right? You deal with the inputs and the outputs. So that's what you see. Everything else is an implementation detail.
So are you able to debug anything in this hidden layers or not?
You are. Yeah, you are. Not with Keras. So today I'm going to show Keras, which abstracts a lot of this functionality, which is also what makes it easier to use. But you are, and if you want to debug, then I recommend doing the fifth module here, which is going beyond Keras, customizing TensorFlow. Because if you use a lower level API, which is TensorFlow, Keras is like an API built on top of TensorFlow, but which adds a bunch of conveniences, makes it easier makes it easier to use. But if you don't need those conveniences, if you want to debug, put breakpoints in the actual training, then it's better to just write that code from scratch instead of just calling an API that does it. And then in that case, you would do this part of the tutorial, and that would give you what you need.
Okay, cool.
Yeah, but with Keras you can't. which is why some people don't like using Keras. But it's also why it makes it so easy for beginners to understand, because you stay like more at the higher level, kind of. Oh, am I in the wrong? Yeah, I'm in the computer vision module.
Yeah, and this is, I mean, a very important thing, understanding neural network architecture. So, any questions? This is a safe place to ask questions.
Yes, this
This
is
is
the
why we
most
have it.
important. Yeah, this is the most important thing you'll get out of this today, I think. If you understand the structure, then the code will be easy to understand. But it's important to understand this. So what happens when you train is that we'll add, we'll have these inputs, and they'll go forward. Like there will be like all sorts of calculations that happen between that connect these nodes. And then you'll have an input, and then you'll go backward. Then there'll be like a backward calculation. It will go forward and backward, and it will do this like many times until eventually it will come out with a prediction like that. That is a good prediction. Yeah.
So what are the numbers that are not 7,000, which is an ankle boot?
Oh yeah. So they will be like, let's see. Let's go to the data. I show this so quickly, but that will make more sense. So this is the labels map. So number 9 is an ankle boot. So if you get the last one, if the last one is the highest, it will be an ankle boot. But let's say if the first one is the highest value, then it means that it's classifying it as a t-shirt.
Oh, I see. Got you. All right. This is just a mapping. Awesome.
Yeah.
So, yeah. Okay.
Okay. All right. So each of these values correspond to a different clothing item. And if they had been the highest, that means that we would be classifying this image as a different clothing item.
Awesome. Thank you. Yeah.
Okay. That's a good question. This is really important to understand.
Yeah. So the first one is the first item on your first array, and last one is the boot that we are looking for. And it happens to be, yeah. Okay.
Yeah, that's it. Okay.
The book car says, I just passed my AI 900 with 955. I feel great. Awesome. Thanks you for sharing.
That's awesome.
Yeah. Have you done any of these exams?
I have not. No.
Yeah. These are the certification exams if you are not familiar, and I haven't done them either. Maybe
well, if you're an expert, if you have any tips as I'm talking, feel free to share them.
Yes.
Yeah.
And how did you prepare? That's an important question.
Yeah, exactly. Yeah, how do you prepare for the exam? Yeah. Well, moving on. So then if we understand this image, then it's actually not that hard to understand the code. Because all the code says is that I have the first layer is a layer that will flatten this 28 by 28 image. So we have this image, and the first layer says, no, I really don't want 28 by 28. I want a 784 kind of flat thing. So typically, the first layer will be that. And then in the middle, we have a dense layer. So a dense layer is any layer that connects every node from the previous layer to itself. So you see here that we have like all these nodes are connected to every node, and so this is a dense layer. And this dense layer has an activation function, which is a ReLU, which we call ReLU. And this ReLU, I represent it here separately, but you can think of it as being part of the same layer. Like it, yeah. In PyTorch, you have to specify them separately. In TensorFlow and Keras, you can put them in one line of code. So that's what it is. And a ReLU function adds non-linearity to the computations. And essentially the way to think of it is that if you don't add them, then it's the same thing as not having that layer, like in terms of, then you may as well not have the layer. So you really do need some sort of like activation function that adds some non-linearity to the code. And there's many different kinds of activation functions. That would be a long topic for a whole show, but here we show ReLU because it's a really popular one. And then
What do you mean by I'm not even going to be able to say that.
yeah,
Non-linearity.
linear. Yeah, so it's like a linear function is something where you have, let's say, 3 times x plus 4 times y plus, I don't know, 10 times z would be a linear function. A nonlinear function would be like 3 times xy plus 4 times z squared times y, because then you're like mixing everything together, like you're mixing the different variables in a more interesting way. And so you need to add those kinds of like more complex operations with an activation function
Okay.
for this to learn better. And at the end, then you just have a dense layer that does not have an activation function, and it's of size 10. Because why is it of size 10? Because we have 10 different classes that we can classify the image as, right? So we have t-shirt, blah, 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 and ankle boot. So there's 10 of them. Therefore, that's why in this case, our output has to be of size 10. And so I put here a dense layer of size 10 with no activation. So these are really the 3 lines of code you need to understand.
Okay.
And they're the, yeah.
One more thing, flattened part.
Yeah.
So you said 28 by 28. I want to turn it into 784 pixels. Is it just basically having a different type of data representation, or any
Yeah, so
other thing to
yeah.
it?
So it's like instead of looking at the data as, so the data is really a two-dimensional matrix. That's really what each image is a two-dimensional matrix, a 28 by 28 two-dimensional matrix. But a neural network needs to have just one long vector, like one long sequence of data. And so the flatten takes a two-dimensional matrix and converts that into a long vector. That's it. So
Okay.
it just flattens everything. Instead of having a 28 by 28, you have a 784 by 1.
Yeah. Okay. Nice. Thank
Yeah.
you.
So that's it. And typically, yeah, so you can, here I created a separate class for the neural network. You don't have to. You could just return this in a function. Yeah, so that could be it. But here I have a class. Either way. So now we can create our network and we can look at its summary. We could just instantiate it because it's a class, right? And we can look at the summary and it will give us here like some details about like about the network, right? And we'll talk about parameters next and trainable parameters. So hold off on that.
Okay, Giovanni says my big question is coming up in the next page. So,
Ooh.
cool.
Okay, let's do a test first, though.
Yes.
What's the output of the neural network used in this sample? Is it the string ankle boot? Is it the number 9, which corresponds to an ankle boot, or a vector of size 10, where the largest floating point number is in index 9, which corresponds to an ankle boot?
Ooh. So on the chat, come up,
Yeah.
throw us a few of the answers. Let's see. Anyone? Giovanni says vector. Oh no, Jenny says vector.
Let's see.
I hope I'm saying your name correctly, by the way. I'm not sure if it's correct.
It is.
Yay! Good job, Jenny.
We moved on. We're now in training. Okay, and somebody has a big question on this. Okay, so I'm going to not run this anymore. The outputs of running are already here, actually, so you'll see. So, but feel free, like as you're coding, to click on the run each time and even modify the code and see how it changes the result. That's really how you learn, right? But this is another really crucial thing to understand. It was the previous image and this image. And these two images essentially kind of explain the concepts of neural networks, I think, in the best way. So the idea when you train, so the next step is to train the model, right? And what does that mean to train the model, right? You get some data in, but how do you train it, right? So training the model is to find all the values of these like orange parameters. So these are the parameters that I was talking about. So there's all these parameters in a neural network that we don't really know the values for those parameters. So there's like these W's and these B parameters. And the training, when we train the neural network, we find values for those parameters. We find the best possible values such that when we input an image of a boot, we get back a boot, right? The output will be a boot. And at the beginning, it won't be. At the beginning, you'll give it a boot and it will tell you that it's something else because all those parameters are incorrect, right? Initially, you just initialize them with random values. You just do literally random values, right? And so that's going to be make all these wrong predictions. But then as you train, as you go backward and forward and backward and forward and backward multiple times, those parameters will keep getting better and better and better. And eventually they're going to be good enough that you're like, okay, I'm happy with these parameters and my network is now trained. And now I can use it to predict, I can input an image and it will get me back it will classify that image correctly, right? So it will get me back the fact that it will tell me that it's a boot.
Yeah. Django says it's like you're teaching a 2-year-olds. And I was actually also thinking, there's a question game in America. I don't know if you know this. Like you ask 20 question, I think it's called. You keep asking, is this a boot? Is this a boot? Basically, and then finally, because it has the answers right in the training data,
Right.
yes or no. Eventually, it understands how to say which one is the boot. Yeah.
Right, and you're actually pretty much explaining this part here, which I was going to explain next, but you essentially already did,
reframe it,
which is great. Yeah, so what this loss is here for. So this loss part was not in the neural network that we saw before. Like we didn't add this to the code and you didn't see it in the previous diagram. So what this loss does, it takes our prediction, which is this y prime, and it takes the real label for that image, which is a boot, which is this y, and it compares them. So it says, how similar is this y prime to this prime? That's what this loss does. And then it will output a number that is just saying it's very similar, it's not very similar, right? And so if it's not very similar, then we go back and do it again, back and do it again, right? So this will keep, essentially this is a measure of how well we're doing. The loss gives us a measure of how well we're doing.
I see.
Yeah.
Giovanni says, this reminds me of the time I had implemented bounded least squares algorithm to predict weights of paint when mixing to change the color design. Do you know what bounded least squares algorithm? Or you can explain, Giovanni.
Maybe he can explain.
Yeah. Let us know on the...
Yeah. Somebody had a question. Somebody said, this is now is going to be like the question that I want to answer.
Yeah, he said the last one, but Giovanni, you mean the last page? Is that... or that might be... yeah, I'm not sure which one. Okay, I'm sure he'll get to it.
Okay. If I don't get to it, please do ask. Okay. So this is a really important image. And now the code. So what we need to do is to, we call it compile. I'm not sure this is like a super intuitive word, but to compile the model, what we do is like we give it information that will allow it to train. And the information that we give it is this loss, because there are many ways to compare a y prime with a y. And we pick one of those ways. So I pick the sparse categorical cross entropy. That's just one. And this one is a good one every time you're doing classes, like you're classifying, like you're choosing a class. There's other things that you can do with a neural network.
Can you give one example?
Yeah, like you could be like, instead of the output being a class, it could be a number.
Oh, I see. Okay.
Yeah. But in this case, we have just one of 10 classes. It can just be 0 through 9. That's it. And then we also choose the optimizer. And the optimizer, in this case, we use gradient descent, like SGD, or stochastic gradient descent. So gradient descent is like the simplest optimizer, and it's also a pretty popular one. Like you see it used a lot. It's good. It's pretty good. There are other more sophisticated ones, and the optimizer will essentially determine how how you, because this is really an optimization problem in the sense that you want to minimize this loss, right? You keep classifying this loss, and the smaller this loss is, the more similar y prime and y are. And to do that, to minimize something, then you're using optimization, which is like an area of math, like a really interesting and really big and complex area of math. And one of the algorithms in optimization is stochastic gradient descent. And so that's what we're using here. We're essentially saying, which algorithm should we use to minimize the loss?
Okay.
Yeah.
Yeah, we're not going to ask you to explain that.
It's actually in the text. So if you are interested, I do explain it in the text.
Awesome.
But I think it's too much detail for a live show.
Our purposes, yeah.
Yeah. So anyway, so and the metrics is like you can say that you want to optimize the loss or the accuracy. In this case, we're actually optimizing the accuracy. Yeah, accuracy is like how many of them do you get right? That's essentially it. And the loss is what's the number that comes out of this loss function, and we want that to be as small as possible. Okay. They're both good metrics. It doesn't matter really which one you use. Okay, and once you've given that information to your model, so once you've given the loss and the optimizer, and you compile, quote, quote, your model using the and the metrics, and so you give that information to your model, then you can just tell your model to fit. And this what does all the training. So this could take hours, it could take minutes, it could take hours, it could take days.
What do you mean by fit?
Yeah, fit is the same as train in this case.
Okay.
You're essentially telling the model to train.
Mm-hmm.
So you give it your data set, and your model already has all this information that's here. It has the structure, it has the loss because you gave it when you compiled, it has the method it's going to use to minimize that loss, which is the SGD. It has values for W and B that were initialized. You don't have to think about it too much, but they are initialized to random values behind the scenes. Mm-hmm. And so when you tell it train, then it starts doing passes, and you give it some data, right? So you say train with this data. And so it's going to go forward and backward and forward and backward. And it's always going to be refining these W and B parameters so that it works well with the data that you just gave it.
Okay. Yes. So I'm thinking one more. Like this is more like 2 years old. You could maybe say for a boot, it's actually a shoes which has high heels or like high neck, whatever you call it. But you can't do that to an animal. For example, the animal studies, you just give a treat, right, to train to figure out something. And this is almost like that, I feel like, right? Yeah. You just say like, is this it? Is this it? Like trying it out. Yeah.
Exactly.
Interesting.
Right.
And we have the answer from Giovanni. Bounded least squares is an algorithm that calculates the smallest sum of vectors while keeping them within a surface area.
All right. Thank you.
Thank you.
Yeah. Okay. And now that we have the model that is trained, right? So this may take a little, it actually doesn't take that long in this project because it's only 28 by 28 images, and I only did 5 epochs. 5 epochs is not a lot. Like you typically would do, epochs is how many times it goes forward and backward. Right? In this case, I'm telling it just go forward and backward 5 times. But in your project, it could be 100, it could be 20, I don't know. Like it depends how, once you, in this case, I'm like, okay, with 5, I can get to 86% accuracy. That's pretty good for me. And I don't want to make it any longer if people are running this at home. So that's pretty good, right? So I just did 5. But if you see that you don't get good accuracy with 5, do 10, do 20, just keep playing with it until you find a good number of epochs.
Okay.
So once you have that and you've gone forward and backward 5 times and you've found all the parameters, you found the values for all these orange parameters, all these W and Bs, then you have a trained model. And once you have a trained model, then you can test it, which we do here with model.evaluate.
So here is the question. How did you know why to choose SGD and not another one?
I would do hyperparameter tuning. I don't.
Okay.
in real life, I would do hyperparameter tuning. That is something that I would probably use Adam. I would probably use STD, and there's parameters that you can pass to each of these. So I would even hyperparameter tune the parameters of the optimizer, especially with Adam. So yeah, so I would do a lot more than just pick something in real life. I'm actually working on a blog post right now that shows hyperparameter tuning
Yay.
for the rate tune. So stay tuned. But that's a really good question. That's it. And my answer to like how would you choose this, how would you choose that, is always going to be the same. I don't know. I think data scientists with a lot of experience start getting they start having a feel for what works and what doesn't, and which scenarios work better with Adam, which scenarios work better with STD. So they may cut a few corners there and may say, okay, I know that this for this one STD is going to work, so I'm just going to use that, and then they hyperparameter tune other things. But in my case, I hyperparameter tune a lot.
Wow. Yeah, it's a lot of work. That's why it's nice to use pre-trained models, right? So you
Exactly.
don't have to do this.
To by hand. Yeah.
And I pasted the link to her blog if you want to stay tuned.
Yeah.
Okay.
Exactly. Yeah. So then anyway, so then you evaluate and you just get the accuracy, like you essentially give it a test data set. So like you give it a bunch of images and you evaluate how well the model does on those images. And hey, 82.5% is not too bad for such a simple network. Yeah.
Especially with five, what was
Five
that one?
epochs.
Yes,
Yeah.
epochs. So my intuition was telling me I would use at least 9 because there's 9 different objects.
Yeah.
Right,
So
you were giving in your images.
yeah, I think that's I think I would actually use more than 9 in this case to really like do it well. Like I don't know that those are too related to the number of classes.
Okay.
They're more like if you pick a really good. They're actually more related to like what kind of optimizer you choose. Like some of them may converge faster than others for your particular scenario. And if you see that it's converging really fast, like let's say if you try 100, and then you get to 5, well, let's say you get to 10, and it's at 90%, and you get 100 to 100, it's still 90%.
Yeah.
Then you can stop at 10, right? Then you don't need those extra 90, right? So it's more that, like you start getting a feel for that and trying things for your scenario. But 5 is very little. Like typically, you don't really get too far with 5, at least not with real world data, right? This is very simple data.
And like real world data like will be much more complex images, I would assume. So
Exactly.
why are they black and white and very pixelized? Is it just for efficiency of this?
Yeah. So they're black and white so that we could just have 28 by 28 instead of 28 by 28 by 3, because it's usually harder for people, especially when you're beginning to start thinking about 3-dimensional arrays. So this way we could just talk about 2-dimensional array that's 28 by 28 and a matrix, which is easier for people to understand, and also easy to understand that you can easily convert a 28 by 28 matrix into a 784 vector. So that's it. That's the only reason why it's not color. And it's 28 by 28 really just to make the size of our neural network here a lot smaller, right? Like if we had something that was 100 by 100, then we'd need like a much bigger input layer because we'd need 1 node per pixel, right?
So Giovanni says probably understanding the math models behind them helps. Is there a list of which to choose depending on data and your goal?
So if you're just doing a simple so there are different neural networks. Here I'm just using a feed-forward neural network, and there are also CNNs and RNNs or LSTMs, or so LSTMs are generally used for NLP, for like text. So
natural language processing.
Exactly.
NLP.
Thank you. Yeah, for language. Not only. They can also be used for time series and things like that, but typically they're for that. And if you want to learn more, then check out the other module in this learning path. CNNs are typically used for images. So if I was actually doing this problem in real life, I would probably use a CNN. But feed-forward neural networks can be used for like images or other things, right? They're just used for in general for like classification problems. They're used for like generic problems. And so that's kind of how I would choose like the major types, whether it's text, image, or not. And the way that I would choose the structure of the neural network would be through hyperparameter tuning.
Okay. And another question from Jen, your data set is in vector, or you need to run the images every time you run the code? I'm guessing you converted to vectors once?
I did, yeah. So when I loaded the data, let's actually go back to the data. When I load the data, I convert them. The data comes in vectors.
Oh, yeah. And it would be really hard to do it in every, I mean, it's always better to manipulate your data once instead of every time.
Exactly, yeah. So the data comes, like when we look at the data here, like training images index 0, this is actually an image, and it's a two-dimensional array. You see that there's like these little arrays. This is this is 28, this is 28, this is 28, and they're all within an outer array, right? So there's 28 of these.
Okay.
So it's 28 by 28 array. And that's another reason why we're not doing color, because then we'd have like a triple bracket here, and then it'd be harder to visualize and to understand what we're looking at.
The simplicity is just for you, so you don't spend too much time running these things.
Exactly.
Okay, cool.
Okay, so then once we have the trained model, then we make a prediction.
So when we say trained model, now we are saying our algorithm is 85% of the time going to give you the right.
Exactly.
Yes.
Yeah. And so what I mean is that I have this model with all these orange parameters chosen correctly. So such that when you enter an image, when you input an image, 85% of the time, it will give me the right classification.
Awesome.
Okay.
So, just letting you know, we have less than 8 minutes.
All right, we'll move on to making a prediction, because now we have a trained model. So let's see. Okay. So now that I have a prediction, now to make the prediction, it's really easy. I just get this image from this URL. I open it. I transform it into an array. So that actually also answers the question that we were just asked, right? So we really, our X is going to be a two-dimensional array. There's 28 by 28. And now we can give it to the model. So now we can do model.predict, and then we can input our image, which is a two-dimensional array, and the array in this case. And then it gives us back a prediction vector, which is that vector of size 10 that we saw earlier with lots of different numbers. And so we say, okay, so what's the highest of the numbers? What's the index of the highest number? And it will tell us it's index 9. And I'm like, okay, so now that I have my map that has all the strings, what's the string that is at index 9? And then it gives us a name, and it gives us ankle boot. And that's it.
Awesome. And NP stands for what was the NP?
NumPy.
NumPy, okay.
NP is NumPy, yeah. So this is the library that I was saying that I love using because it helps to deal with n-dimensional arrays. So 3-dimensional, 4-dimensional, it just deals with that really nicely. So I use NumPy all the time.
Okay.
Yeah.
Cool.
And just out of curiosity, this is actually the values we got back.
So for that image,
yeah.
So you say we got back. What is can you show us the raw image that you gave? Because training data and
this is it.
Testing is different. Oh, I see. I see. So
I just gave it. Yeah, I gave it one single image, which I got from this place. So if you click there, you'll get it. So I open it. I transform it into an array because that's what we'll need to use in the model, like pass to the prediction in the model.
Mhm.
And then here I just show it. I just show that as an image.
Awesome.
Yeah.
Hey everyone, this is so a lot of information. So please let us know if you have any questions. And if not today, we can actually answer it next time. So this is our GitHub repository discussion panel. You can go there and ask us any of your questions, and we'll be happy to answer next time. Okay. Hey, and I should give many thanks. Thank you. Thanks for the time and effort. Thank you, Jengir. Thank you for joining and asking really nice questions. Have you tried feed it to the map of Italy?
Why don't you try that and let us know?
Yeah.
For next time.
Can you change the training image on the Learn module? Is it possible?
Sure.
To give? Okay. Yeah. Oh, that's nice.
Well, not on the Learn module, because I would change it for everyone doing the Learn module. But
yeah. Sorry. I can't read the name. Tijaz. I hope I'm saying it right. Was asking about HoloLens. I promised him to answer that question. HoloLens is doing great. Lots of companies are using it, and they do have a lot of events actually happening as well. If you go to the meetup page and HoloLens meetup, you can see all of the events that are coming up. I'll paste it. Tune in next Friday with Sats, back with Swati Gars to talk about building computer vision models using AutoML for images. Ooh, this is a nice follow-up. Awesome.
It is. I like it.
Really nice. We have 3 minutes left. Shoot all of your questions. And if not, can we do an overview? Is it too little?
Sure.
This is your challenge to summarize everything in 3 minutes.
Sure. So we saw code to do to train a neural network or a model, and I just wanted to show this, right? So we looked at how you pre-process the data that you'll use in your neural network, how you create your neural network, how you define it, how you think of it, how you understand it, and how you write code for it. What does training a neural network mean? What you do when you train it, and how do you train it? Like, what code do you write to train it? And then how do you test it? And once you have a neural network that is trained and that gives you a good result in your testing, then you can use it to make a prediction. You can give it an image of Italy and then get back a boot, hopefully.
Yes. Thank you, Giovanni. And if you do try it out, please let us know. And on GitHub, or we have our Twitter handles. I don't know how to display that. So, all right. Well, I don't know why it's not displaying, but it is on details on YouTube. So you can reach us on Twitter or on GitHub. Oh, yes. Here it is. I should have put
there
that.
You go.
Okay, cool. Take care.
Yours isn't there.
Yeah, it's mine bad. I'll put it. And we are going to be back on October 22 and continue our conversation from here on. And
and specifically, we'll be talking about Azure ML. Like, how would you do this in the cloud? What I showed today locally. Now, today I only showed how to do this locally, but how would you do it in the cloud? And also, what about cognitive services? Like, what if you don't need to do this at all because there's already a cognitive service that already works for you?
Yeah, thankfully, I don't. Personally, I love it. So one really challenging part is finding the data, right? And when you use something like cognitive services, you're using the data from the years and years of research at Microsoft on the level of Microsoft, which is really cool. And it's really easy to use. But I'm so happy to understand the algorithms behind it too. Thank you so much for your expertise. How to spot bias wherein process is the best. So we have to do an episode just for this. This is a very important point. And we have 30 seconds left. So we won't be able to do that, but we will in the future.
We will absolutely talk about that next episode. We actually have that already on our notes to talk about in the next episode. So we'll do that.
Oh, and our next
Seth is here.
Yes. Look at the excitement. I mean, everybody loves Seth.
Of course.
And remember, our next episode is in October 22, and Seth is going to talk about, wait, I just read it.
AutoML.
AutoML next week. And you can
Yeah.
ask a lot of your questions to him too. Well, he'll have funnier answers.
For sure.
Yeah, don't miss the show.
All
Bye.
right. Bye.